Hi, my name is Patrick Reagan. The Computer Primary Component Series will go in depth of the individual components that make up the computer. This video is called RAM, which discusses the characteristics of RAM, including double data rate or DDR memory, RAM packaging, including DIMMs and SODIMMs, multiple channel motherboards, error correcting code or ECC, and virtual RAM. It also discusses low memory and troubleshooting memory. Random access memory, or RAM, is considered the primary memory and is the short-term memory of the computer. It provides temporary storage space for data and program codes that are currently being used. The amount of memory is a major factor in determining how fast your computer will operate. It is called random access memory because the information can be accessed non-sequentially. The processor can access one memory address and then jump to another memory address. While memory is one of the fastest components on the motherboard, it is considered volatile since it loses its content when there is no power. RAM consists of billions of memory cells that consist of tiny capacitors to hold the bit of data with the transistor acting as a switch. If the capacitor is charged, the bit is a 1, and if the capacitor is discharged, it is a 0. Unfortunately, capacitors leak whereas a charge will drain away. Since we're talking about very tiny capacitors, the capacitors will empty in a few milliseconds. The memory controller constantly reads the memory and writes it back to keep recharging the capacitors. This refresh operation happens automatically thousands of times per second. This is the reason that RAM is dynamic, because it has to be dynamically refreshed all of the time or it will forget its content. Of course, when you shut off your computer and you have no power, the capacitors will quickly drain and you'll lose its content without the refresh. Early RAM performed action each clock cycle. However, when double data rate or DDR memory was introduced, the DDR memory performs actions twice per clock cycle, once during the rising edge of the clock signal and one during the falling edge of the clock signal. This doubles the transfer rate without increasing the frequency of the clock signal. When RAM is being accessed, the DDR memory will perform a prefetch of the next block of memory and copy it into the RAM with the hope that it will be the next data or code needed. Since the data and code that is prefetched is usually needed next, the memory performs faster. As the various versions of DDR was introduced, the number of bits prefetches has increased. Throughout the years, there have been DDR, DDR2, DDR3, DDR4, and DDR5. As of today, April 3rd, 2025, the standard DDR RAM for most computers is DDR5. As you can see from the chart, every iteration of the DDR protocol sees significant performance increases over the previous generation, including clock rate, transfer rate, and bandwidth, while reducing voltage. It should be noted that later for these iterations of DDR, they also introduced lower voltage versions of DDR3, 4, and 5, which are labeled as DDR3L, DDR4L, and DDR5L. Lower voltage means less heat and less power consumed. Today, RAM packaging includes dual inline memory modules or DIMMs and small outline dual inline memory modules or SODIMMs. RAM is added by inserting the RAM circuit board into the RAM slots. Desktop and tower computers will typically use DIMMs, and laptop computers, some mini computers, some office printers, and some networking devices will use SODIMMs. Each iteration of DDR is not compatible with other iterations of DDR. The DDR3 DIMMs had larger contacts than DDR4 and 5 and had only 240 contacts. DDR4 and DDR5 DIMMs have 288 contacts. However, to make sure that you don't install the wrong memory chip into the motherboard, the notch is located in different locations. When you install the DIMM, the notch on the motherboard must match the notch on the DIMM. Motherboard will only support one type of memory. Similar to DIMMs, SODIMMs also vary the number of contacts in the notch. DDR3 SODIMMs had 204 larger contacts, and DDR4 and DDR5 had 260 contacts. All three have different locations of the notch. In previous videos, I've already showed you how to uninstall and install DIMMs and SODIMMs in the computer disassembly and reassembly series of videos. This video shows how to uninstall DIMMs by pulling the two tabs apart. Then, to install the DIMMs, you just insert the DIMMs into the socket until the tabs click into place. The memory chips usually have one or two notches to make sure the correct RAM chip is inserted in the memory socket. If the notches do not line up properly, the RAM chip is not made for the specific motherboard you are using. SODIMMs are uninstalled by pulling the two tabs apart until the SODIMMs pop up. You then just pull the memory out of the socket. To install the SODIMMs, you insert the SODIMMs at a 45-degree angle into the socket and click the SODIMMs into place as the two tabs click to hold the SODIMMs into place. Today's DIMM and SODIMMs are 64-bit devices, which allows 64-bit of data to be read from or written to at once. Multiple channels means that the motherboard memory control chip handles processing of memory requests more efficiently by handling multiple memory paths simultaneously, which increase the rate of transfer between the computer's memory and the CPU. If your motherboard supports only one channel, and you insert one memory module, you're communicating at 64 bits. If you insert two memory modules on the same motherboard, you are still communicating at 64 bits. Today, most motherboards support dual-channel memory, which allows two modules to communicate simultaneously on separate channels so it can transfer twice as much data. If your motherboard is dual-channel and you insert two memory modules, you can communicate up to 128 bits at a time. However, if your motherboard has dual-channel and you insert one memory module, you are still communicating at 64-bit. Some high-end workstations and servers support triple, quad-channel memory, and hexa-octa-channel. If your motherboard is quad-channel, you would have to install 4 memory modules to get the full performance. When you have multiple channels, the memory modules must match within a channel, including the same memory type, same memory features, same speed, and same capacity. Most motherboards will have different colors to indicate a multi-channel grouping. While some motherboards will have the channel slots and colors grouped together, others will alternate the slots. Check your system or motherboard documentation to determine how many channels a motherboard has and which memory slots go to which channels. There are two forms of error control used in memory. The legacy form of error control is parity, and the newer error control is error correction code, or ECC. Parity error control looks at 8 bits at a time. It counts the number of bits and stores the 0 or 1 into the 9th bit, called the parity bit, to ensure that all 9 bits is an odd number. For example, if you have 0, 1, 1, 1, 0, 1, 1, 1, and you count the number of ones, you have 6, which is an even number. Since it's an even number, a 1 is put in the parity bit, which makes all 1s, including the parity bit, as an odd number. On the other hand, if you have 0, 1, 1, 0, 0, 1, 1, 1, and you count the number of 1s, you have 5, which is an odd number. Since it's an odd number, a 0 is placed in the parity bit, which makes all 1s, including the parity bit, as an odd number. When the system reads memory, it will check the byte with parity bit to make sure the count is still an odd number. If the total memory is an even number, your system would generate a parity error or parity check error. Unfortunately, parity won't always detect an error if 2 bits change, because the bits would still be an odd number. In addition, parity cannot correct errors. The obvious downside of using parity memory is you have to provide the 9th bit for every byte you have. Today, because of the additional cost, parity memory is rarely used in modern computer systems. A better form of error control is error correction code memory, or ECC memory, which can detect and correct most common kinds of internal data corruption without user intervention. ECC uses a 7-bit code that is automatically generated for every 64 bits of data stored in RAM. ECC can detect up to 4-bit memory errors and correct 1-bit memory errors. ECC memory is used in higher-end computers and network services where data corruption cannot be tolerated. Its disadvantage is an additional memory chip, and it is slightly slower than non-ECC memory. While it will only slow RAM by 1 to 2% performance, it is well worth the accuracy. Today, ECC memory is common in servers, workstations, and other systems where data integrity is paramount. Since ECC RAM is more expensive, and this slight performance hit, ECC RAM is less common in mainstream systems. Memory is generally divided into 3 distinct categories based on these traits. Unbuffered non-ECC, which is standard consumer RAM, has no signal buffer and no error correction. It is typically found in standard gaming and office PC memory, which typically uses the Intel Core or AMD Ryzen processors. Unbuffered ECC is designated as UDIMM ECC, has no signal buffer but includes error correcting chips. It is used in entry-level servers and specialty workstations, which typically use Intel Xeon W or AMD Threadripper. Registered ECC, which is designated as RDIMM, includes both a signal buffer and error correcting chips. It is used in high-end enterprise servers, which typically use Intel Xeon or AMD EPYC processors. A motherboard is strictly limited by its chipset and CPU architecture, meaning it will typically only support one type of memory, or at most allow unbuffered ECC memory to function in a degraded non-ECC mode. You cannot freely mix these types and try to force an unsupported type, which will cause the system to fail to boot. Virtual memory has been around for years, whereas disk-based acts like RAM, which allows the operating system to load more programs and data. Parts or all of your programs and data to be accessed are constantly swapped back and forth between RAM and disk so that the virtual memory looks like regular RAM. Virtual memory is mostly implemented with demand paging and demand segmentation. Since disk is much slower than RAM, when accessing virtual memory, it is slower than accessing regular memory. It is why it is recommended that you use an SSD drive for better performance. The RAM and virtual memory are broken down into chunks of information called pages, which is monitored by the operating system. A paging file is a block of hard drive space that applications use like RAM. Paging files may be referred to as pagefile, pagefile.sys, swapfile.sys, pagefile, and swapfile. For Windows, it is a best practice to set the paging file size to equal to or greater than the total amount of available physical memory. In Windows, you can configure the virtual memory by clicking the Start button, opening Settings, and navigating to Performance options as shown on the screen. When you click the Advanced tab, you click the Change button, and you can change the location and size of the virtual memory. It is also recommended that you have multiple physical drives, you move the paging file to a different drive than the operating system, and that you place the paging file on the faster drive. Question you may have: how much RAM should you have in a computer? For casual light users who surf the internet and access their email, you should have at least 8 GB of memory. For intermittent users, which would be most business users, you should have at least 16 GB. Professional users, gamers, and graphic design people should have at least 32 GB. If you're using a RAM-intensive program including 3D modeling, high-definition photo, or video editing, you'll need at least 64 GB of memory. 64-bit Windows 10 needs a minimum of 2 GB, but it's recommended that you have at least 8 GB. Windows 11 needs a minimum of 4 GB, and it's recommended that you have a minimum of 16 GB of memory. Adobe Photoshop needs a minimum of 2 GB. If you're doing heavy photo editing, you should have at least 32 GB of memory. If you're running low on memory, you will likely see one or more of the following symptoms. Files don't open immediately, or programs are slow to load. You are unable to run multiple programs at the same time. There's a lag when you type. You have an error message that says you're out of memory or the computer is low on memory. You have random freezing. You open up Windows Task Manager or similar program is showing you are using 80% or more of your available memory. Page files are being overutilized and page and file usage is above 75%. While the CompTIA does not dig into these parameters, you need to use Windows Performance Monitor or similar program to look at these values. If you find yourself running low on memory, you should check for amount of RAM used and how much disk space you have available. Verify that the amount of RAM is what you have installed and verify that you're using less than 80% of your available memory. Close all applications and reboot the computer to free up memory. Sometimes, applications don't release memory as they should, which is known as memory leak. If you find a program that has a memory leak, you need to look for updates or patches for the application from the vendor. Check your processes and look to see which process is using the most memory. Check for malware. Add more memory. Consider increasing the paging file if you have less than 1.5 your physical memory. Decrease your load by not having as many applications running. Windows Task Manager is a handy tool to see how your computer is performing. To open Windows Task Manager, you can right-click the Windows taskbar and click Task Manager. By clicking the Performance tab and clicking Memory, you can see that the system has 64 gigabytes of memory as shown in the top right corner. Toward the middle, it shows that 48.9 gigabytes is available. This system memory is in a good place. You also see in the left side that you're using 14.8 gigabytes out of 63.8 gigabytes, or 23% is of the memory is being used. If you click the Details tab, you can see which programs are using the most memory. You can click the memory header to sort by memory. Right now, CompTIA Studio is using the most memory. If you suspect you have bad memory and you just installed memory and you had problems immediately after that, the problem is most likely the memory you just installed. Therefore, you should verify that the memory is installed correctly and you have the correct RAM for your motherboard you're using. You can run a memory diagnostic tool to verify the RAM. In addition, you can replace the memory with known good memory. Alternatively, you can try the memory in a known good system. If the RAM is okay in another system and you try different RAM in your system, it could be the motherboard. You should check your BIOS settings to see if any of those settings could affect memory. Then consider resetting BIOS settings to the default. Remember that motherboards can cause processor failures, memory failures, and storage failures. In these cases, you need to replace the motherboard. Of course, the motherboard should be one of the last things you swap out because it requires the most work. Windows includes a Windows Memory Diagnostic, which you can open by clicking the Start button and type in Memory, and clicking Windows Memory Diagnostics. While some information will be shown during the test, the results will be shown in the Event Viewer in the system logs. Question: you have a laptop computer that has 8 gigabytes DDR4L soldered onto the motherboard and has one available RAM slot. What type of RAM should you install? Answer: you should install an 8 gigabytes DDR4L SODIMM. The laptop computer will use SODIMMs, and you should use the same type and size of memory that you're already using. Question: you're having problems opening programs and you receive messages that you have low memory. What should you do? Answer: increase virtual memory so that you can have more available memory. You should reboot the computer to refresh the memory. Question: you have a new computer and you tried to open multiple large spreadsheets that include lots of graphs and they failed to open. What should you do first? Answer: increase the amount of virtual memory. Remember, the question was asking what you should do first. So you would be increasing the amount of virtual memory. If that works, you then consider adding more memory or replacing memory so that you have a higher amounts of memory. Question: what are the two forms of error control found in RAM? Answer: parity and ECC. Question: what package type of memory is used in laptop computers? Answer: SODIMMs. Question: what type of memory error control will correct a single bit error? Answer: ECC. Question: your workstation has dual channel motherboard. What memory should you install on the motherboard? Answer: you need to install memory that is made for the motherboard. In addition, you install memory in pairs, and the pairs should have to be the exact same memory, including type, size, voltage, and features. Question: which of the following can be used as an extension of RAM? Choose three answers. Answers: virtual memory, swap/paging file, and swap partition. Question: which of the answers listed below refers to a valid SDRAM module combination that can be installed on a single PC motherboard? Answer: none of the above. Question: certain types of RAM take advantage of the additional bit in order to detect whether a data error was occurred. This extra bit is used to store information about the count of bits set to the value of 1 in a given string of data, typically 1 byte. Examining the values of additional bit at different stages of processing allows you to detect whether the data has been corrupted or not. What is the name of the extra bit? Answer: parity bit. Question: what is ECC type RAM? Answer: can detect and correct errors. Question: true or false? The color coded memory slots on the motherboard indicate that a given motherboard provides support for the multi channel memory architecture. Answer: true. Question: what advantage of the performance benefits offered by multi channel memory architecture requires? Choose all that apply. Answer: memory modules of matching types, memory modules of matching speeds, memory modules of the same capacity, and installing modules in appropriate memory slots, slots of matching color on the motherboard. For more information, visit these sites. In summary, random access memory, or RAM, is considered the primary memory and is the short-term memory of the computer. The amount of memory is a major factor in determining how fast your computer will operate. RAM is known as dynamic RAM because the RAM has to be dynamically refreshed all of the time or it forgets its content. When DDR memory was introduced, it performed actions twice per clock cycle. All versions of DDR memory are not backward compatible with previous DDR versions. Motherboards are built to support only one type of memory. Today, RAM packaging consists of dual inline memory modules, or DIMM, and small outline dual inline memory modules, or SODIMMs. RAM is added by inserting the RAM circuit board into the RAM slots. Multiple channels means that the motherboard memory controller chip handles processing of memory requests more efficiently by handling multiple memory paths simultaneously. Error correcting code, or ECC memory, is a type of memory that can detect and correct the most common kinds of internal data corruption or errors without user intervention. Virtual memory is disk space that acts like RAM, which allows the operating system to load more programs and data. Thank you for watching this video. The next video in the series will be Computer Primary Components, Part 7, Computer Cases and Fans. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.